We will talk about a very hot topic today about fine-tuning large language models. And in today's episode, we'll do fine-tuning for OpenAI GPT 3.5, and we will use the dataset that we generated on previous episode. And this dataset is built on company knowledge base, company handbook, and we split this documentation to chunks. And for every chunk, we generated a list of question and answers. And this dataset we will use today. And before starting, I would like to talk about why companies would like to fine-tune models. And first reason it is uh, GPT 3.5 is pretty capable model. It's learned from whole internet, and you can ask and questions about mostly everything and get pretty good results. But what is not capable, it is some proprietary data. So if your company has proprietary data and you would like to teach a large language model to know this data, to know this information, fine tuning is one of the options. And second reason that you may would like to teach or fine tune large language model, it is to get more predictable results. So you can instruct large language model how to behave on your prompts, and with after the fine tuning, model can will be much more predictable. And I would like to start with the structure of the process. So as already said, we have knowledge sources. We generated a data set with large language model. And right now we will use this data set and source model, GPT 3.5 Turbo, to create new model uh, that we will use for text generation. And I would like to start with initial setup. That will set some variables, import libraries that we'll use later. And first step, it is very straightforward. It is to create fine-tune engine. And it has three parameters. So this is Turbo 3.5, GPT 3.5 Turbo. It is a source model that we will fine-tune. So you can select any models that support fine-tuning and in OpenAI. Next one, it is our data set. And third one, it is optional. If you already run this job and would like to check a status of this, you can propagate, set this variable, set this parameter, and identify the fine-tuning job. If you do it first time, you just need to comment this and run without this parameter, and that will create new job for you. I already did this action, and fine-tuning takes a couple hours, so that is why it doesn't fit video recording. And so I did it before recording this video, and you can see this my fine-tuned job description. It includes ID, model, source model, fine-tuned model, organization ID, etc. So, and the status is succeeded. That means that we can start using this model. So you also can list with OpenAI API. You can list all the fine-tuning jobs that you did before. You can see a number of epochs. It's three. So we train or fine-tune our models on the dataset 3 times. You can see train tokens, etc., and no errors. So you also can get fine-tuned model using this library. So yeah, and in next part of this episode, I would like to test and see how it works and compare it with baseline GPT 3.5 Turbo. And I use a chat OpenAI library for this. I created a message, specify system message, the same as I use for fine tuning, and I specify a human message like what is the purpose of body program in the Maytech company, and our baseline model. And the result is quite short and general, and uh, and we can see that GPT 3.5 already knows something about the program in general and about medtech company. And the reason can be also because this handbook was already published in the internet, and there's high probability that GPT 3.5 was trained on this data. But it doesn't, even though if this public information, fine tuning can improve the quality and to make it um, more predictable results. So let's check how works fine tune model. And you can see that the answer is provides much more information. And this information was provided through the fine tuning. So the model gathers information during fine tuning, and that improve the results. And one thing the, that I noticed that fine tune model works slower than baseline, sometimes significantly slower. Here you can see that answer we got on 1 second slower, but sometimes I get 3 or 5 times slower results. And the last test that I would like to do it is join and test two methods that we already know. It is fine-tune GPT 3.5 model, plus we will use retrieval augmented generation. So we will combine fine-tune model with relevant information, relevant context from our vector store. And you can see that we use retrieval QA, LangChain library for this, and we fetch 5 documents and add them as a context. Let's run this. Yeah, you can see it's even slower, 20 seconds. Often I get not really predictable results based on latency perspective. So it really depends on how significantly what is the load on OpenAI APIs right now. So on evening that can be much more slower. On the morning or during the day it can be variety can be different. So and let's check what we have here. So we have some short information about what we have in the documents that we use for context. And here you can see the result. And for example, you can see the 3 months that we didn't have before. So you can see the 3 months is from this document, but we don't have this yet. So combining two techniques will provide better results. So, and vector database provide us the most relevant, up-to-date information. Plus, if we have fine-tuned model that provides also some additional context from fine-tuning, and also it provides more predictability, more consistent results. So that's all for today. Thank you very much.